Okay. Yeah. So this question says, what is the units digit, or the ones place of 13 to the power of 2012? Okay. So for this question, the idea is, notice that like 13 to the power of 2012 is a very large number, right? Like this is a humongous number. But luckily they're not asking us to calculate the whole number. Like 13 to the 2012 will have like a bunch of digits. Like it'll probably have like over it'll have over 2,000 digits. Like it's going to be a really large number. But luckily the question doesn't ask us for the entire number. They just ask us for one digit. They ask us for the units digit. And usually, sometimes in harder questions, harder variations of these questions, they might ask for like the tens digit or the hundreds digit, things like that. But in this case, they ask for the units digit, which is like slightly more like not as complicated. So the idea is like we can look at the number 13, and we notice that's a 2-digit number, but like we only care about the ones place, right? So we can kind of disregard this 13 and instead replace it with 3 to the 2012. Like we can pretend this 1 doesn't exist, and the reason is because we only care about the units digit. And doing this kind of relies on like a fact kind of known as like modular arithmetic, which might be like slightly more advanced. But in this case, like you only have to worry about the last digit. So instead of looking at 13 to the 2012, you can just look at like 3 to the 2012 instead. You can just instead look at 3 to the 2012, and yeah. So basically, now what we do is, this still kind of looks pretty intimidating, right? Because 3 to the 2012, like even though it's not as large as 13 to the 2012, it's still a pretty large number. So, but the idea for these kinds of questions is, again, if you're given like a really large number like this, like almost like a really large amount of the time, like there's going to be some pattern, right? So if you look at 3 to the 1, the last digit is 3, right? If you look at 3 to the 2, the last digit is 9. If you have the number 3 to the 3, 3 to the 3 is 27. So 27 times the last digit of 27 is going to be 7. Then you look at 3 to the 4. 3 to the 4 is going to be 27 times 3, which is 81, which has units digit 1. 3 to the 5, you would take 3 to the 4, which has units digit 1, and multiply by 3. So 3 to the 5 has a units digit of 3. 3 to the 6, you would take this 3 and multiply by 3. You'll have a units digit of 9. Let me erase this. And notice that like we're starting to see a pattern in cycles of 4, right? Like it turns out if we were to go on to like 3 to the 7, that would give us 7, and 3 to the 8, that would give us 1. Notice that this repeats in cycles of 4. It goes 3 9 7 1, 3 9 7 1. So it repeats, like the units digit repeats in cycles of 4. And notice that like 3 to like this number here, like in this case 4, and 3 to the power of 8, in this case, 3 to 8, they all end in a units digit of 1. So in general, if you were to continue this pattern, 3 to the any number that's a multiple of 4, like 3 to the 4, 3 to the 8, 3 to the 12, 3 to the 16, and so on, they'll all have a units digit of 1. And like conveniently, we see that 2012 is divisible by 4. So that tells us that 3 to the 2012, if we were to continue this cycle of 4 pattern, it would have a units digit of 1. And that would give us choice A.